Here's the answer to day 2, problem 1. Find the domain and range of this function. Let's begin with the domain. What numbers could be used for x? Because x is in the denominator of a fraction, that denominator cannot equal 0. So let's figure out what the restricted value of x is by setting the denominator not equal to 0. Subtract 4 from both sides, and then divide by 2. We find out that x cannot equal -2, but x can be any other real number. So for the domain, x can be any real number except -2. Now let's do the range. What numbers can be outputted by a function that starts with 3 and divides by different numbers created by putting in different numbers for x? We could create positive answers and negative answers, but the one answer that cannot be created from this function is 0. So the range for f of x is all real numbers except 0. It might be interesting on this function, knowing that x cannot be -2 and that the value of the function can never be 0, to see what a graph of this function would look like. Here you see this function graphed using a graphing calculator. Over here on the side, I've typed the function in. F of x is equal to 3 divided by 2x plus 4. And you see the graph shown in red on an x and y axis. Notice the vertical asymptote running through -2 on the x-axis. That was the restricted value of x. X cannot equal -2. There are no points on the red curves that have an x value of -2. That is its asymptote line. You notice the red curve getting very, very close to the asymptote line moving up. And similarly, this section of the graph, that red curve is getting closer and closer to the vertical asymptote line at x equals -2. You'll remember that the range was all real numbers except 0. And sure enough, there is a horizontal asymptote line running through where the function would have the value of 0. And the curve gets close to that line, moving to the left, and gets close to that line, moving to the right. So here is a graph of that function, and you can see the effect of those restricted values on the domain and range. Okay, and back to the bellworks. Day 2, problem 2. Solve the quadratic equation by factoring. Let's first look for a greatest common factor, but there is no number that divides into 6 and 31 and 35 other than a 1. So let's try factoring this trinomial using the FOIL pattern. We need a pair of numbers that multiply together to create 6x squared. The choices are 6x times 1x or 3x times 2x. Let's begin with the pair 3x and 2x. Then for these numbers, we need a pair of numbers that multiply together to make 35. Choices are 1 and 35, or 5 and 7. Let's use the numbers that are closer together, the 5 and the 7. If it doesn't work, then we will try the 1 and the 35. Now we have to figure out where to put the 5 and the 7 so that that middle term turns out to be positive 31. If we put the 7 over here and we put the 5 here with positive signs, then the outer product is 21x and the inner product is 10x, and those do combine together to make the 31x. If we had first tried the 7 here and the 5 here, we would find out that that did not make 31x, and we just would need to erase those wrong choices and try them in this order here. Now we can set each factor equal to 0 and solve for x. This first one is going to turn out to be -5/3. And over here, this will turn out to be -7/2. There are the two answers to the quadratic equation using factoring method.